All right, so in this video, we're going to go through sample question 104 from the Society of Actuaries ExamP list of sample questions. The question reads, a joint density function is given by the following, where k is a constant. We need to calculate the covariance of x comma y. Okay, so I actually see almost two ways to go through this problem. One is a very quick shortcut method where if you're very familiar with certain rules, you'll be able to quickly figure out the answer to the solution, and one is a more standard approach to this kind of problem. I'm going to go through the shortcut method first. All right. One property you should be familiar with is that if the density function f of x comma y can be written as a product of the functions of x alone and the function of y alone, then x and y are both independent. Okay, and then just sub x, y here. This implies independence. All right, and if two random variables are independent, the covariance would be 0. So are we able to write x and the functions of x and y separately so that their product is equal to f of x comma y? Well, if f of x is equal to k x and f of y, say, is equal to just 1, then f of x comma y is actually equal to f of x multiplied by f of y here. And what are we left with? Well, this implies independence, so that means the answer must be B0. Okay, now that's a very nice solution, and it's something that would save a lot of time, right, for you to recognize this. But there are definitely many instances where they'll give you two random variables that are not independent, so how would we figure it out that way? Well, you should be familiar with this particular formula. The covariance of x comma y is equal to the expected value of xy minus the expected value of x multiplied by the expected value of y. Okay, so we're going to need these three pieces of information. In order to do that, we kind of need to know what k is, right? So how do we figure that out? This should be a very familiar procedure from a lot of univariate questions you've done. We're going to integrate over the entire region. So here's what we're going to do. 1 should be equal to the integral going from 0 to 1 and 0 to 1, right? 0 to 1, another integral is 0 to 1 of kx. And it seems to be easier to do a dx dy in this situation. I mean, difficulty is not going to actually change, but for now, I'll just go dx dy. Now, let's see, integrating here, I get 1/2 kx squared. So 1 is equal to integral from 0 to 1, 1 over 2 kx squared from 0 to 1. Obviously, the thing's going to be 0. And this will just be 1 is equal to integral from 0 to 1. Dy is still here. Integral 0 to 1 of 2x squared. Sorry, not 2x squared. 1 over 2k. dy. And then this is just going to be 1 equals 1 over 2k y from 0 to 1. And yeah, that's just simply 1 equals 1 over 2k. So k is equal to 2. All right, so our actual density function is 2x. Great. Now how do we get the expected value of x? Well, the expected value of x, let me grab a new sheet of paper, should simply now be e of x integral from 0 to 1, 0 to 1 of 2x multiplied by x, which is 2x squared. So 2x squared dx dy. And this will equal 0 to 1, 2 over 3 x to the third dy, going from 0 to 1. This will just be 2 over 3. Dy, and yeah, that's just going to be, final answer is going to be 2 over 3. Now let's find the expected value of y. The same thing, 0 to 1, 0 to 1, integration of 2x times y, so 2xy, and I'll do dx dy, and that's going to be equal to 0 to 1, x squared y from 0 to 1 dy. That gets me just 0 to 1 y. And as you notice, this is just like a lot of calculus at this point. Dy, which I can quickly figure out is just going to end up getting me 1/2. Okay, so I found e of x, e of y. What's the last thing to find? E of xy. Okay, and we just grab a separate sheet of paper right here. Okay, so let's see in frame. Yep, the expected value of xy equal to, once again, 0 to 1, 0 to 1. Should be experts at this point. Of 2x times xy, which is 2x squared y, and I'll do dx dy. And this is going to equal, let's see, 0 to 1, 2 over 3, x to the third y from 0 to 1 of dy, and then evaluating 0 to 1, right, that's just 2 over 3y dy, and that gets me 1 over 3y 0 to 1, which is just 1 over 3. Okay, so now we can plug them into this formula here, right, to find the covariance. Well, the expected value of xy is 1/3. So covariance of x comma y is 1 over 3 minus the expected value of x, which we found to be 2 over 3, minus the expected value, multiplied by the expected value of y, which is 1 over 2. And you'll find this ends up equaling 0, getting us that other answer. Okay? Now, obviously I showed you the first step. Why did I take the extra, 6 minutes to show you the other step? To really demonstrate why knowing certain rules can not only just cut your time in half, this is so much more of a quick solution than something like this, right? And it just required a little bit of outside the box thinking, right? However, of course, the pressure of actually be sitting in the exam and taking it, I might not have thought of this when I was first taking that exam. So obviously be very familiar with this. If you have any questions, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That definitely helps me out. And if you want to see more questions like this, I got a playlist, Sample ExamP questions. Check it out. Thank you for watching. I hope this helps.